Hello, Junkyard Inventors. It's been a while since I made electronics videos for you on this channel, although there are plenty on the radio channel. So, by the way, I invite you to subscribe by clicking on the link in the description. Today we're going to see something fantastic to use in PC power supplies and get voltages around 200 or 300 volts. Like, I don't know, for that tube amplifier, for the electric guitar you've been thinking about, or those physics experiments with ionization chambers, where you need a higher voltage than what the power supply itself provides. And we've talked many times about how versatile these power supplies are and how easy they are to get. But the voltages they provide are low. At most, you can get about 24 volts if you use the plus 12 and the minus 12. But in this video, I'm going to show you how you can get much higher voltages. And in the video about the hybrid amplifier that I made with old television tubes, I already showed you quickly how to do it. But today we're going to do it with all the details so you can use it in your projects. A warning. Here we're going to work with high voltages, which are very dangerous. So if you don't have experience, don't do it here. These are no longer low voltages that don't give you a shock. We're going to generate very high voltages, even higher than the line voltage. So be extremely careful. If you don't have experience, don't get involved in doing these things. Seriously. Among the advantages of using these power supplies to obtain high voltages, we can point out that first, they are very lightweight. Generally, a conventional power supply used to have very heavy and expensive iron transformers. Also, the fact that it works at a high frequency, around 25 kilohertz, compared to the 50 hertz of a regular power supply. This means that the filtering of the direct current voltage we get requires much lower capacitance values compared to linear power supplies. For example, a 10 microfarad capacitor is more effective than a 1000 microfarad one in a regular power supply, a linear supply with a transformer. This is mainly because in switching power supplies, since there are so many cycles, we're talking about 25 kilohertz, that is 25,000 cycles per second, compared to 50. The capacitor doesn't have time to discharge, and the filtering is much better even with less capacitance. Of course, these capacitors are smaller and cheaper, which is very important. And another advantage of the switched mode power supply is that it works by turning a transistor on and off at high frequency. And its efficiency ranges between 80 and 95% compared to a linear power supply, which has terrible efficiency, between 30 and 50%. So, well, now do you understand why switching power supplies have won the war against linear power supplies? No, in almost all projects, the power supplies used are switching power supplies. All right, let's see how to set up the circuit to get these voltages, which allow us to do a wide variety of experiments, even power vacuum tubes, radio tubes. For this project, we'll use a power supply that's working. Of course, I have several that I've been fixing recently. And we'll also need another power supply that's in the junk pile, one we've already scavenged quite a bit, that we have for taking components from that old, broken power supply, let's say. We're going to take out two big capacitors. These ones here, they're the two filter capacitors. They're usually 300 microfarads with 200 or 300 volts of insulation. Also, we're going to take out the chopper, which is this transformer, this yellow one you see here. We're going to take that out too. We're going to take it out. 4 fast switching diodes. Don't remove these that are at the input because those are not fast switching. You need to remove the ones that are on the cold side, let's say, on the low voltage side. Normally, those diodes start with fast recovery or ultra fast. Don't use regular diodes. Well, we're also going to need to remove a 1.5 nanofarad capacitor with insulation of 1 to 2 kilovolts. They're these little blue ones that are usually at the input of the power supply. And we're also going to need a 1 ohm resistor, about 2 watts, 50 ohms. There are these ones here. There are several. They can be from another value. They can even be up to 100 ohms. There wouldn't be a problem because we're going to use that to make a snubber network that protects the diodes from voltage spikes. What you do is assemble a diode bridge with the 4 diodes, just like you're seeing here, and use it for filtering. We're going to put the 2 electrolytic capacitors in, but we're going to put them in series, not directly, but one after the other, to increase the insulation. You see that they have 200 volts, and well, by putting them in series, we'll be able to rectify voltages up to 400. Because the networks add up afterwards. It's nothing more than a 1.5 capacitor and a 50 resistor in series. We're going to place that at the high voltage output of the auxiliary chopper transformer that we took from the power supply. Scrap, right? Here we see the cloud networks already installed and the whole module is assembled, also the high voltage one. Now that you can see everything, you can see the 150,000 ohm resistor I placed between the positive and the negative. This is a resistor that is used to discharge the filters when we disconnect the power supply. I recommend you put it in. Notice that we connect the bridge rectifier and the filters. The primary winding of the auxiliary chopper is the one that has only 2 pins. The secondary windings usually have several pins, and they also have a bundle of wires coming out from the top. There, in that bundle, we will also connect a wire that will go to the power supply, which works in the same place as the chopper, also to the bundle of wires that is connected to ground. So we connect that to ground, and now we connect another wire from the working power supply to any of the outputs of the chopper. From the cold side, let's say from the side that goes to the low voltages. We will test with a multimeter, plug in the power supply, of course, and measure the voltage that is rectified in the auxiliary chopper. For example, with the cable connected to this first point, here I have 142 volts. Now I'm going to connect to the next point. Notice that now I have 245 volts, 100 volts. Be careful touching there because the shock you'll get will be historic and dangerous. You can also play with the pins of the auxiliary transformer, switching them to get the voltage that's suitable for our project. If we need 130 or 140 volts, we'll leave it at the first point. If we need 300 or 250 at the second, and so on. Generally, there's space inside the power supply to place that auxiliary chopper, so you can put it in there, either glued or screwed in, however you prefer, so that it stays nice and secure. Be very careful with the high voltage output cables. They must be perfectly insulated and labeled to avoid accidents. As you can see, it's not difficult, and you can get significant voltage for projects that require that kind of high voltage. I hope you liked the video and found it useful. If so, give it a like and share the video on your social networks. And if you're not subscribed, do it right now and hit the bell so you get notifications when I upload new content. You can also join, and in that case, I'll add you to a WhatsApp group with the members. Rewards. Thank you so much for watching the video, and see you next time, God willing.